Good day, good people. Welcome to JJ Tech Tutoring. To this one, I will be doing the combination of Laplace transform, right? So that means it's the first shifting theorem, right? So as you know that the Laplace transform of f of t is equals to infinity 0 e to the power negative st f of t. We did this, right? We did this. I even did some provings. So now here we'll be dealing with the combination of the Laplace transform, right? We all know that f of s minus b is the Laplace transform of f of t multiplied by e to the power bt, right? So now that means if you are given something like f of t e to the power bt, the Laplace transform of this, you need to apply this, right? So that means now that's what you have to do. Now for an example, I don't like doing theoretically teaching. I love to do maths practically. Now say the Laplace transform of t, right? So the Laplace transform of t is what? Is 1 over s2, right? So we focus on the exponent, then we put the exponent at the numerator, or we take the factorial of the exponent and put it in the numerator, then from there we divide by the n plus. Actually, what we do is that, because some people don't understand what is this Laplace, because some of them didn't watch my previous videos. So now say you are given t to the power n, so that means t to the power n is factorial of n divided by Sn plus 1, right? So that's how we deal with it. So basic of Laplace, we happen to have this. Now we are going to transform it. We're going to actually shift it, right? So now say you're given this t b e to the power bt, right? So now that the one that is not having a lot of things is just like this, but then if now it's multiplied by e to the power bt, so that means it's going to move. So it's going to be 1 over squared because it's t, right? Squared because it's t. So it's this one that was here plus 1, then it's squared, right? So now it has to move now. It has to be s minus b, right? It has to be s minus b, right? Now say what? Let's do another example. First thing first, I will do the Laplace of that particular question and also do the shifting, right? So now if I am to do the Laplace transform of sine 2t, if I am to do the Laplace transform of sine 2t, right? My Laplace transform of sine 2t, it will be, as we know that sine at is equals to a divided by s squared plus a squared. We know this, right? So that means it's going to be a is 2 over s squared plus 2 to the power 2. So it's 2 over s squared plus 4, right? So now in this Laplace transform, that's how we solve it. But then now, how do we solve it when it is shifted, right? So now that means it's e to the power bt, then sine 2t. So that means it's going to be what? Use your common sense. Use your common sense, even if you have never done such, but then with your common sense, you can now get the drift. Because now you have to do the Laplace transform of this. Then inside the s, we substitute by s minus this. S minus this. So that means it's going to be 2 divided by, instead of s squared, we have to say s minus b squared plus 4. Right? So this is the shifting Laplace transform, or the combination chapter. Right? So what you have to know on the table, because some people don't have the table, but otherwise, e bt t to the power n, this is equals to, so that means this side is ft, this side is fs, right? So now it will be factorial over s minus b n plus 1, right? So this one is equals to this. So now e bt sine at is equals to a over sine minus b squared plus a squared, right? So same thing with cos, cos at Same thing with cos. So remember that in S we substitute by the shifting. So cos you know that cos AT is equals to S over S squared plus A squared. But then here, because instead of S now we have to put S minus B divided by S minus B squared plus A squared. This is our cos. This is our cos. So we just have to always know that Laplace shifting, it's always like this. It's always of, we always have to move with this B. We always have to try by all means to move with BT. But then now we have to try by all means to solve realistic questions now, questions that are real, right? We have to solve the questions that are real. Now f of t is equals to e3t sine 5t, right? E3t sine. So that means here is that b that we were talking about, right? So what is it that we have to do? First thing first, remember your stuff. Remember your stuff now. I remember your stuff now. You remember this first, because if you get this wrong, you are out. Because we are doing the Laplace transform of sine 5t, right? So when we multiply that sine 5t with this e to the power 3t, now we are applying the shifting theorem. We are applying the combination theorem. Now, first thing first, focus on this. It's now 5 over s squared plus 5 squared, right? Right. So this one is what? It's 5 over s squared plus 25, right? Now the shifting enter. The shifting enter, because now s is equals to s minus 3, right? S minus 3, because now this 3 is that b that we used to have. Now we have to do what? Final answer, it's 5 over s minus 3 squared plus 25. Plus 25. So that's what we do. That's what we do. And that's the only correct answer. That's the only correct answer. Now let's do the second example. The second example, it's t squared e to the power negative t. So this side, we have b is equals to negative 1, right? B is equals to negative 1. And the rule says s is equals to s minus b, right? Right? So now let us do the Laplace transform of t squared. The Laplace transform of t squared is 2 over s to the power 3. It's 2 over s to the power 3. Then from there, we have to shift with this. We have to shift with this, because this, our b, is negative number. But then we always have to use this, right? So now, we are just going to say 2 over s plus 1 cube, right? Right? So this is the only correct answer. This is the only correct answer. Now say what? Say you are given something like f of t is equals to cos. We all know how cos works. Immediately you see something that is in the denominator. You must know that this particular thing is going to change, and it's going to have sign if ever it has to be in the equilibrium with the numerator. So now it's e to the power negative 4t cos 3t. So just to be in the nice way so that we can be able to deal with it. Now, say what? What is it that is our, what is it that is our b? What is it that is our b here? What is it that is our b? Our b is negative 4. Our b is negative 4. So when our b is negative 4, that means first thing first, let us solve this. Let us solve this. So this one is just s over s squared minus 3 to the power 2, right? So with that, because we have already did the Laplace transform of cos, now we have to include, right? So it's going to be s over s plus 4 squared minus 9. So this is how it needs to be. This is how it should be, right? So we have this, we have this, we have this. This is the only correct answer. So now stay tuned and make sure that you subscribe and hit the bell icon, because soon I'll be uploading the Laplace transform of inverse. I'll be doing the inverse Laplace transform. Since we have done the first Laplace transform, we have done the second Laplace transform, that is having combination. For now, you can just send the questions that are very, very hard in the comment section. Then I do them for you in a video explaining it, knowing it very well. And then when you're doing Laplace transform, you also have to familiarize yourself with the partial fractions, because if you are having a very challenging chapter, partial fractions needs to be there, because each and every challenging chapter is having questions that in them you need to be manipulative. You need to break them down, and then you break it down, you have to be very, very, very well with partial fractions. I'll one day do a video explaining how partial fraction works, so that you can be able to apply the knowledge of partial fractions into Laplace transformation, so that you can be able to deal with all of those things. Thank you so much. Like, share, and comment if you have something to comment about, and always subscribe. Thank you.